Benchwork 1 is a great way to practice PLC programming. We will use the Do-More Designer Simulator to program this scene from the Machine Simulator software suite. This suite was previously called EasyPLC but has changed its name to describe the industry-leading learning software better. The Machine Simulator suite comprises several machines that can be programmed, or you can design your own. One such machine is Benchwork 1, which transfers red pills from the collection area to the exit belt conveyor. Using the Do-More Designer PLC software, we can practice programming by connecting the Do-More Designer PLC simulator to the Machine Simulator Bench 1 machine. Communication will be done using Modbus TCP Ethernet. The Benchwork 1 machine incorporates a manual and automatic mode to operate. Automatic will incorporate a sequencer using a counter in the PLC program. This is the easiest way to program sequencers. The 5 steps for developing PLC programs will be used to program this machine. Let's get started. Detailed information contained in this video can be found at accautomation.ca. A link has been put in the description below. If you have not watched the other videos yet, there will be links in the description below that will start you at video 1. There will be links to the rest of the videos in the series as well. Step 1. Define the task. The first step in PLC development for any project is defining the required task. We need to understand what needs to be done. Launch the Machine Simulator 4 and access the Machines menu. The Benchwork 1 Practice 01 option will be seen from all the pre-configured machines. This will be the machine that we will program. As you move the mouse over the picture of the machine, you can select the icon on the top right side. This will show you the machine's description. The object is to transfer the red pills from the collection area to the exit belt conveyor. To do this, you must use the pneumatic clamp of the linear loader to collect the tablet from the loading area and deposit on the axial movement carriage. To take it to the turner area, which must activate the aspiration system to transfer the tablet to the table. 2 operating modes must be programmed, manual and automatic. When selection is in the manual position, pressing each button should allow you to move the system to the positions manually indicated on the button labels. In automatic mode, pressing the start button should automatically carry out the sequence explained above. Correctly program the stop and emergency stop buttons to stop the system. The Machine Simulator Bench 1 has a demonstration mode. This mode shows you the operation so you can better understand what needs to be accomplished. Take some time to explore the 3D virtual environment using the navigation menu at the top of the window. The default selection allows you to move freely without colliding with any components, while the first person and third person provides different perspectives. By exploring the demo mode, you can better understand how Benchwork 1 operates in manual and automatic modes. This will help you to develop the PLC program to control the Benchwork 1 machine's actions effectively. Once we understand the task and we have familiarized ourselves with the Benchwork 1 operation, we can proceed to the next step in developing the Do-More PLC program. By following these steps and gaining hands-on experience with Machine Simulator Learning Suite and the Do-More Simulator, you will be well on your way to mastering PLC programming and applying your knowledge to real-world applications and scenarios. So let's continue our journey and move on to the next step in the process. Step 2. Define the inputs and outputs. Defining the inputs and outputs is critical to effectively programming the Benchwork 1 PLC. Inputs are signals or data received by the PLC, while outputs are signals or data sent by the PLC to control external devices. By understanding the inputs and outputs, you can develop a program that reads the status of the inputs and activates the appropriate outputs. While still in demo mode, select View I/O to display the inputs and outputs required for this machine. This PLC programming example will require 15 digital outputs and 23 digital inputs. These PLC I/O are for the machine's physical running and do not include additional registers or bits required for programming. In the case of the Benchwork 1 PLC, the inputs include the status of the push buttons on the control console for all the manual operations. These inputs will determine the machine's control. The outputs include signals to move and create the red pills. If you are unsure what an output or input is doing, start the Benchwork 1 machine in start mode. Select View I/O at the bottom of the Benchwork 1 Machine Simulator window. You can manually run Benchwork 1 without any control or PLC connection. Select the outputs on the left side to turn on and monitor the inputs on the right side. Defining the inputs and output establishes the communication between the PLC and external devices. This allows the PLC program to monitor the inputs and continuously decide based on their status. The program can then activate the appropriate outputs to control the Benchwork 1 operation. The Machine Simulator will communicate to the Do-More Designer PLC simulator using Modbus TCP or Ethernet. The Do-More series of PLCs use a fixed Modbus memory area. This area can be seen in the following chart. Step 3. Develop the logical sequence of operation. Developing a logical sequence of operation is critical in programming any PLC. To ensure a smooth and efficient program, it is important to create a flowchart, sequence table, or detailed information that thoroughly outlines the process that needs to be controlled. This will help answer questions about what happens during a power or pneumatic air loss, or if any output or devices fail. Also, it is essential to determine if redundancy is necessary. By understanding all aspects of the operation up front, you can save yourself a lot of time and work and prevent the need to rewrite the PLC program logic continuously. As a PLC programmer, it is vital to have a comprehensive understanding of the sequence and operation of the machine before starting the programming process. This can be achieved by asking questions or reviewing existing documentation to ensure a clear understanding of the logical steps involved. Our system has two operating modes, manual and automatic. In manual mode, the Benchwork 1 machine can be controlled manually through the push button console. If a push button for the pick, left, and right are held, the tumbler stays in that position. If the button is released, the tumbler returns to the home position. Since we can only manually turn on one item at a time, if the suction is on and the tumbler is in the left position, it will turn off the suction. In automatic mode, select or switch, the start button flashes, indicating how to start the machine. Once this start button is pressed, the stop button lights up, indicating how to stop the operation. When the machine initially goes into automatic mode, the control sequencer resets. Here is a sequence of steps for the automatic mode of the Benchwork 1 machine. Step 0, initialization. Grip is open and the X-axis is positioned left. Step 2, a part is created for the red pill. Step 2, grip closes to take hold of the pill and the gear advances, or the carriage. Step 3, the X-axis is positioned right. Step 4, grip opens and releases the part. Step 5, the gear reverses the carriage. Step 6, suction turns on and the tumbler moves right, picking up the pill. Step 7, tumbler moves left. Step 8, the suction turns off and the tumbler returns to the home position. Step 9, the conveyor turns on for 2 seconds, advancing the red pill. The sequence will then reset after the time delay. By developing a logical sequence of operation, you can create a PLC program that effectively controls the Benchwork 1 PLC and ensures its smooth and reliable functionality. This step sets the foundation for the subsequent development of the Do-More PLC program, which will be covered in the next section. Step 4. Develop the Do-More PLC program. Developing the Do-More PLC program is the next step in learning how to program the Benchwork 1 machine. This step involves translating the logical sequence of operation developed in the previous section into the program the PLC can execute. It is important to understand the programming language used by the PLC. The Do-More PLC uses ladder logic, a graphical programming language representing the control logic in a series of rungs. Each rung comprises inputs, outputs, and logical functions that determine the system's behavior. You can start building the ladder logic program by using this logical sequence of operation as a guide. Start the free Do-More Designer software. We have already started programming the machine by selecting the new icon on the main page to start a new project. Using the documentation editor from the main menu tools, we map the Benchwork 1 machine's inputs and outputs to the corresponding PLC addresses. The first rung of the program will handle the operating modes of the Benchwork 1 machine. Everything is allowed to operate when the emergency button is on. The start button will flash if the manual automatic input is on and the automatic start C0 is not on. The stop button light will be on if the automatic start is on. Selecting the start button and not selecting the stop button will start the automatic start bit. This is used to steal the start button. The manual start bit is set C1 if the selector is not on. The next few rungs list all the outputs. Conditions for manual and automatic operation are shown. The first output is conveyor advance. It will be on if the manual button is selected and the mode is manual, C1. When in automatic and the sequencer count equals 9, the output and timer will be on for 2 seconds. The conveyor light on the panel will operate when the conveyor advance output is on, manual or automatic. In manual mode, the tumblers on the left and right are activated with manual buttons. If the buttons are not pressed, the tumbler home will be activated. Automatic mode moves the tumbler right at counter sequence 6 and left at counter sequence 7, which the sequencer reaches the value of 8, the tumbler returns home. The tumbler suction will pick up the red pill in manual mode. The push button will turn on the suction. The suction automatically turns off if the tumbler is moved to the left above the conveyor. This will allow the red pill to drop onto the conveyor belt since you can only press one button. In automatic mode, the tumbler suction will be on steps 6 and 7. The push button light will activate manually and automatically if the tumbler suction is on. Gear advance and retract will carry the red pill from the x-axis to the tumbler. It is in the x-axis when advanced and the tumbler when reversed. The claw is attached to the x-axis and helps transfer the red pill from the axis to the gear. Manual buttons on the control panel include a claw open and claw close button. In the manual mode, a start-stop circuit controls the claw. Since the claw has no sensor, timers determine whether it is fully opens or closes when in automatic mode. Rungs 13 and 14 control the x-axis left and right. Like all the program's other rungs, they can be controlled manually or automatically. The red pill creator also includes a timer to ensure the part has been created. Once our logic accounts for all the outputs, we can use a counter to control the sequencer. The counter up input will use the counter accumulator as the reference for the next step. Conditions for advancing to the next step are put in series. Step 0 looks for the claw open timer and the x-axis left sensor to be done before advancing to step 1. Step 1 looks for the part creation timer to be done before advancing to step 2. This continues until you reach the end of the sequence. The counter sequence will then be reset when the selector is first set to automatic or when the conveyor's last step timer is completed. An end statement will indicate that this is where the program ends and to repeat the scan. Save your program. It is important to always save your program during programming. Select the Do-More Sim icon. This will start the PLC simulator. The Do-More Designer simulator will run independent of the Do-More Designer programming software. When returning to the Do-More Designer software, you can then see we are connected by the simulator by the icon and the status bar at the bottom of the window. Select the right PLC icon. This will transfer our program to the PLC simulator. The mode icon on the main menu will allow you to change the PLC mode from the program to run. This also shows the PLC switch position. Select the run mode for the PLC. The Do-More simulator will have a switch position that can also be changed to control of the mode of the PLC. Select System Configuration under the Tools menu of the project browser. This will display the System Configuration window. Under the internal Ethernet port configuration, you will see the IP address of the PLC simulator. Besides this section, there will also be a Modbus TCP IP, Modbus TCP server configuration. Ensure that this is enabled. This PLC simulator will act as a Modbus TCP server to the EasyPLC Modbus TCP client. A Modbus client will send requests and the Modbus server will respond. Make a note of the IP address. We will need this to set up our Modbus client in the next step. By following a systematic approach and referring to a logical sequence of operation, you can develop your robust and efficient Do-More PLC program for the Benchwork 1 machine. This program will serve as the machine's brain, controlling its movements and ensuring its safe and reliable operation. Step 5. Test the PLC program. To ensure the functionality and accuracy of the Do-More PLC program for the Benchwork 1 machine, it is essential to test the program thoroughly. Utilizing Machine Simulator MS is an efficient way. Using the MS, you can simulate the operation of the Benchwork 1 machine without the needing physical hardware, and you minimize the risk of damaging during the testing phase. We will use Modbus TCP on our Do-More PLC simulator to communicate with the EasyPLC machine simulator. Call up the Benchwork 1 machine simulator in start mode. The current status of the machine simulator will be at the bottom of the screen. Currently we have no PLC connected. Select I/O drivers on the bottom middle of the screen. The machine simulator I/O will be displayed. Ensure we select more I/O than the number required for our Benchwork 1 machine. The EasyPLC driver is selected by default. Under the driver pull-down menu, select Modbus driver. This driver will communicate Modbus TCP or Ethernet and Modbus RTU serial. Select the Configure button. We can now enter the information for our Modbus driver. Select TCP/IP. This means the Ethernet port on your computer will communicate to the Do-More PLC simulator. The digital inputs from MS to the Do-More PLC will be MI1 to MI15. This will start at address 0 due to the offset of 1. Digital outputs from the MS to the Do-More PLC will be MC1 to MC23. This will begin also at address 0 due to the offset of 1. Select the OK button. You will now see the inputs and outputs specified for the Modbus driver. We can now manually assign the driver outputs to the PLC inputs and the driver inputs to the PLC outputs. However, the automatic assignment works well and will save you time. Select Automatic Assignment from the driver option in the main menu. This will automatically assign the PLC simulator I/O to the machine simulator I/O. Select Start Driver and exit the main menu. On the bottom left side of the window, the driver communicates with the Do-More PLC simulator with a green light. Select View I/O to see the machine simulator's input and output status. Ensure that Do-More PLC is in run mode. We can see the operation of our Benchwork 1 machine. The inputs and outputs of the MS will respond to the PLC controller. Using the Data View window of the Do-More Designer programming software, we can also watch the inputs and outputs operation. We can now manually move the red pill or do this automatically. Using Machine Simulator or MS to test the program will ensure that our program works. Troubleshooting is quickly done without damage to any physical hardware. This testing phase is critical in ensuring the safe and reliable operation of our Benchwork 1 machine. You can practice your modification and debug by modifying the Benchwork 1 machine operation in the following way. Change the automatic sequence to transfer 5 red pills and then stop. After stopping, the conveyor should also run until all the pills are off of it. Calculate the rate of red pills transferred for this machine in number per hour. Let me know how you made out in the comments below. If you enjoyed this video, please hit the like button below. If you have any questions about the video, please leave a comment below and I'll do my best to answer it. If you want more information about us or you want our free ebooks on numbering systems or robust data logging, please click on the link in the description below to get it. A new video is posted every Monday, so make sure you hit the subscribe button so you get more videos like this in the future. Remember to click the bell beside your subscription to actually receive those notifications. Thanks so much for watching. I'll see you next time. Stay safe.